Every day, Indian villages generate massive amounts of wet waste. Between food scraps, agricultural residue, and raw cow dung, a tremendous volume of biological material piles up. Right now, local municipalities treat all of this strictly as a liability. To get rid of it, village councils, or panchayats, bleed through their municipal budgets. They spend heavily on transport vehicles, diesel fuel, and manual labor just to haul this material out of town and dump it into hazardous open-air piles. While villages pay to throw these raw materials away, the national economy pays to replace them. In the 2023 to 2024 fiscal year, India imported roughly 177 lakh metric tons of chemical fertilizers to keep its agricultural sector running. There's a second massive import drain happening right inside rural homes. Families rely heavily on globally priced cooking fuels, or they fall back on burning wood indoors, exposing themselves to severe respiratory hazards from the dense smoke. Rural economies are caught in a devastating loop. They drain their local budgets to dispose of biological raw materials, and then drain their wallets a second time to import the exact fuels and fertilizers those very materials could have produced. We can break this loop by treating waste strictly as manufacturing feedstock. This concrete digester is the core of a village circular biocenter, a decentralized green enterprise that processes local biological matter into commercial products. Building one doesn't start with buying machinery. It starts with a 30-day waste audit. Before any money changes hands, operators measure exactly how much organic material the community actually produces, identifying the precise daily inputs and seasonal shifts. The strict rule of this business model is to secure your customers first. Operators sit down with the community and sign agreements with local schools to buy the fuel, or specific farmers to buy the fertilizer, long before the processing capacity is even built. To protect the machinery, they also have to eliminate the biggest operational risk, plastic contamination. This requires enforcing a strict green and blue bin separation at the household level, so the organic feedstock arrives completely clean. Once operational, artificial intelligence acts as a local economic multiplier. Software predicts waste volumes based on local events like festivals or market days, and then maps out the most efficient collection routes to slash fleet fuel costs. AI also monitors the physical health of the digester. Sensors track internal temperature and acidity in real time, issuing early warnings if the mix gets too watery or a pump underperforms, preventing expensive mechanical shutdowns. By applying modern data analysis and a customer-first design approach, a chaotic municipal chore is organized into a predictable, low-risk manufacturing operation. To see exactly how the math works, this financial ledger maps out the balance sheet for a standard 1 ton per day capacity biocenter. We evaluate the economics across capital expenditure, expected revenue, and operating expenses. First is the CapEx. It takes roughly 30 to 45 lakh rupees to build the plant, buy the transport vehicles, and install the safety gear. This initial block is typically funded through government grants, corporate social responsibility funds, or bank loans. Once running, the plant generates its first revenue stream, biogas. A 1-ton facility produces enough gas annually to equal 432 standard LPG cylinders. That provides an energy value of roughly 3.9 to 4.3 lakh rupees. The second revenue stream comes from the byproduct. The digester yields 80 to 120 tons of organic fertilizer a year. Selling this directly to nearby farmers generates another 1.6 to 4.8 lakh rupees. The third stream is service fees. By charging a tiny monthly collection fee to households, plus commercial rates for hotels and markets, the center adds another 4.6 lakh rupees. Combined, the plant projects a total annual value of 10 to 14.7 lakh rupees. Against that revenue, we subtract the OPEX. It costs about 7 to 9 lakh rupees a year to pay local salaries, cover electricity, and maintain the machinery. Subtracting those operating expenses leaves a net operating profit of 2 to 5 lakh rupees a year. A properly managed, decentralized waste facility pays for its own upkeep and generates a surplus. That surplus creates an immediate social dividend. A 1-ton facility requires a dedicated staff, creating 5 to 7 permanent local green jobs. These are typically managed by women's self-help groups or trained rural youth who run the daily logistics. The local panchayat gets immediate municipal relief. Because the waste is processed directly inside the village, the transport distances drop to almost nothing, and those toxic open-air dumping sites can be permanently closed down. Compare this self-contained, hyper-local system to the massive industrial plants required to import and refine global commodities. When global supply chains experience price shocks, the Village Biocenter keeps producing its own fuel locally. Out in the fields, farmers play the long game. By integrating the Biocenter's organic fertilizer based on strict soil testing, they gradually rebuild their soil's water retention and nutrient cycle, slowly stepping down their need for expensive chemical imports without shocking their crop yields. Garbage is a design flaw. By redesigning the system, a village stops paying to throw away its own resources and instead turns an economic drain into the foundation for local financial and energy independence.